Here we go. Write this. Write 1 minus I in complex in polar form. Okay. So what you gotta do with this is you draw your Argand diagram. Upon completion of your Argand diagram, it's the point 1 minus 1. 1 along the real axis minus 1 on the imaginary. So 1 across, 1 down. That's you there. Okay. Then you're gonna link your value. Goes down here. Now we have two things we have to do. We have to find out our angle. Now it's 1 across, 1 down, which means that's a 45-degree angle. Or basically you can say tan A equals 1 over 1. Tan inverse it, you get 45 degrees. Okay. As discussed earlier, your angle is 315 degrees because it goes all the way around. Right. Your polar form is getting the hypotenuse of this triangle. It's a 1 squared plus 1 squared, which gets you 2. So the answer is root 2. Okay, so root 2. Then once you do root 2, what we're going to get next is okay, so root 2 bracket. I like your style. 315 plus I sine 315. Now we need you to get those every time. Okay. Use the Moivre's theorem to find this to the power 9. So if you imagine this is our complex number z, right? This is basically z to the power 9, isn't it? Same thing. So what we're going to do is we're going to apply the Moivre's theorem, which is going to be I can probably just I'm just going to rip this off here. There we go. Make it easy on myself. A 9 here and a big 9 out here. Then I'm going to use that 9 and multiply it in. So it's going to be z9 equals root 2 to the power 9. And then that's going to be, what's 315 by 9? Actually I have it, 2,835. Plus I sine 2,835. Close bracket. Okay? Now, there's a problem in your calculator, right? I'm going to show you the problem I had in the calculator was, I did root 2. Okay, and then I did that to the power 9, and the thing kept coming out like that. Okay, and I couldn't really get it in third form. It's just a fault in the calculator, but let me show you a way around that. Well, instead of doing that, I'm going to do root 2. I'm going to do it to the power of 8 instead. And to the power of 8 is 16. Yeah? So to the power of 9 will have to be 16 root 2. Because you've got to multiply by the extra root 2. And you can just check that with your, just multiply that answer by root 2. Just make sure it's the same thing. It's your 22.63. I don't understand why you didn't do it in the first place, but I just didn't. Okay? Now, cos 2835 is 1 over root 2. And then sine 2835 is minus 1 over root 2i. The root 2's cancel. And we're going to get 16 minus 16 I. Game with that? Now, we have here is a complex number z has a modulus greater than 1. The three numbers z squared and z cubed are shown in the Argand diagram. One of them lies on the imaginary axis as shown. That'd be this one here. And label the points on the diagram to show which point corresponds to which number. Find the argument theta, the argument of z, the argument of z. Right? The argument is the the angle. Yeah. Now let me explain what happens. If I have a number, okay, if I have a complex number and I say z equals 5, and I'll just make up any angle I want. Cos 30 plus I sine 30. Is everybody happy with that? Okay. Now, what happens when I do z squared? Z squared is going to be 25. That's going to be cos to the power 2 is going to be cos 60. Yeah. Plus I sine 60. So do you understand that by having a modulus bigger than 1, my distance increases? So the first one's 5 away, the second one will be 25 away. The next one is going to be 5 to the power of 3, which is 125 away. So it's rotating, and the angle's changing, which means it's rotating. It's rotating, and its distance away from the origin is increasing. So it's an outward spiral. Okay?
So is that kind of like that? Is that actually
Nope. Spiral outwards. Right here.
I think like the increase is going up in cubes is kind of weird.
Spiral outwards. Okay? Now, let's go the opposite way. I make up a complex number randomly. This complex number is a half. A half squared means the next one's going to be a quarter. The one after that, said 3 will be an 8, and that will be 3 times the original, which would be cos 90 plus I sine 90. Everybody agree with that? Okay. Sorry? Yeah. Now, it's going to take, how many complex numbers is it going to take until they're back in line? Do you know why the argument is 30? The next angle that's exactly the same as that is 390. Would you agree with that? 390 is exactly the same value as cos 30, I sine 30. So it's going to take 13 of them, isn't it? It's going to be said to the power 13. It's the next time they're going to be. If you imagine your first complex number is out here, that's said 1. It's going to be said 13 until they're back in.
Wait, how do you know that's
line?
said 13?
Because it's 390. It's the same as 30. And remember, it's your angle to the power on the outside. So 13 times 30 is 390. I'll give you another example, right? We'll really hit this point home here. If I had I'll go bigger this time, right? If I had 2 cos 60, I sine 60, and that's said to the power 1. Yeah? The next angle that's the same as that is what? 2 cos 420 plus I sine 420. Now you got to remember, to turn 60 into 420, we have to do it to the power of 7. So it's going to be 2 to the power of 7, and then it's going to be said to the power of 7. So the next one that's in line, so if you've said 1, the next one that's going to be in line with said 1 is going to be said 7. They're going to have the same angle, the same argument value, so to speak. Okay? It's basically your angle, whatever angle you have, divide it into 360, and that's how many are in between them. So if you divide 360 by 60, you get 6. So that hence the gap between Z1 and Z7. In the last example we had 30, didn't we? 360 divided by 30 is 12. This means Z1 and Z13 are in the same direction. Okay, you keep spiraling outwards. You start off here, you keep spiraling outwards, and then eventually at Z13 you'll be back in line again. Okay. Now, once again, everything is in this chapter. It's all on video again. Okay. Now, let's go back to this question. Is actually much easier than that is. Okay. So let me show you what's going on here. So the first thing is, because you know it's spiraling outwards, you can just come along with a ruler and just go, you're the closest, you're the second closest, you're the furthest. Oh, Z1, Z2, Z3.
Wait, how did you notice off the top of your head that they were spiraling outwards?
Because it states that the modulus is greater than 1. If the modulus is greater than 1, it's an outward spiral. If I change that question and I said less than, what way would the answers be affected? Said 1, said 2 being the same because it's the middle one, and said 3.
If the modulus is 1, is it just
circle, yes.
That makes sense.
Okay.
That was the last one was a circle.
Yeah, I don't think the last one was quite a circle, but we'll see. Okay. Now, what we have is we've labelled Z1, Z2, and Z3. Now, that to be honest, like that is the very last part of complex numbers. one tidbit of information. That's a lot of marks going for that small amount of information. Once again, if you do not hit every chapter, you are potentially missing out on something. Okay? Now, find the argument. Now, here's the hard one. Okay? So what we're going to do is we're going to make up a random complex number. R equals cos theta plus I sin theta. You would agree that's the polar form of a complex number. Yeah. Now, what's set 3 going to be then? Using the Moivre's theorem. Set 3. So r to the power 3, and r to the power 3 increases this distance away from the centre of the circle. So it's the difference of this green line, and now all of a sudden it's been cubed, so now it turns into the length of this new, I was meant to be a blue line, but the green line, the green line represents r, the blue line represents the length of r cubed. Is that right? Now, the angle changes as well into cos 3 theta plus 3 theta. Now, here's the interesting one. Okay, you know that the y value is negative. Now, remember what we said earlier. This point here, see this point here? It's technically represented by r cubed cos 3 theta and r cubed sin 3 theta. Remember we did it earlier when we were drawing the diagram in the last question? This is your x coordinate, and then combine that, and then this part here is your y coordinate combined together. Okay? Now what we know is that the r cubed cos 3 theta equals 0. Sin 3 theta, excuse me, equals 0. What value of sin theta equals 0? Sin 90. Oh wait, is it? Sin 90 is 0, isn't it? Oh, sorry.
So it'd be 0 and...
Oh, just give me a second.
Wait, it's the cos value at 0, isn't it?
Yeah, 3 cos 0 is 0.
Sorry lads, excuse me. It's the I value is grand. It's actually the x value that's 0. So it's actually, because that makes no sense, because we know it's 90 degrees. It's going straight up, so it's actually it's the x value that's actually 0. So it's r cubed cos 3 theta equals 0. Now what we're going to say is, what value of cos is 0? You can see that's at 90 degrees upwards. Yeah? So we can say that 3 theta equals, oh yeah. Now, the problem with saying, if you don't mind me saying, see the way we started off out here? See the way we started off there? That means it actually can't be 3 theta equals 90. The reason for that is your very first angle is an obtuse angle. Okay?
Good morning, sorry for the intrusion of class. Today's announcement.
You can see that your very first angle, your theta angle, so to speak, is an obtuse angle. That means that because we're multiplying it, 3 theta has to be a number that's bigger than 90. Okay? So it's still 90, but it's the plus the 360. So it's actually a 450 degree angle is responsible for this. Your 360 going around in the first circle. You go Z1 is an angle in between 90 and 180. And then you jump the same angle again when you're going around the second time. And then the third time around, you jump up by the same angle, and you're left at 450. So what you know is that 3 theta equals 450. That means that theta equals, anybody? Theta equals 150. So the argument is 150. Now, to really understand this, okay, now to really hit this point home, we've got the answer. It's 150, but let's really hit this point home so we understand it. I'm going to make up the complex number now that fits the criteria. Complex number is going to be 2 cos 150 plus I sin 150. Can somebody tell me what the point is going to be? 2 cos 150, anybody? And somebody do 2 sin 150? 2 cos 150 is minus root 3. And the other one is 1. You can see there a slightly acute angle. That's this point, root 3 and 1. Let's do z squared. Z squared is going to be 2 squared, and it's going to be cos 300 plus I sine 300. What do we get this time around?
2.
It's going to be, was it?
2
And 2 and
2 or 3.
2 plus?
No, 2 and minus 2 or 3.
Minus 2 or 3. Okay, so 2 and minus 2 or 3. And where would that belong? 2 across, 2 minus root 3 down. So it fits that angle absolutely perfectly, doesn't it?
In this case, you're just making it for modulus. Yes.
Sorry?
The modulus is still just made up in this case, like those two.
The modulus?
Yeah. You have two.
I've made up the modulus, yes. And then finally, z3 is going to be 2 to the power 3 cos 450 plus I sine 450. And what you get this time around?
0 and 8.
And there's your third point there, 0 and 8. And look, they're all 450. Now, here's the interesting thing, okay? It rotates 150 degrees every time, correct? So the starting off point is here. So that rotates 150. This one rotates 150. And then the next one is not going to be in line with it because it's going to rotate another 150 down here. So it's not going to be in line for a while. Okay? So that's what I'm trying to get at. It's not going to be in line for a while. Okay? So you have to keep going around until it's back in line. Okay? Cool.
That's actually